Okay, for 7.5, we're solving equations, and we're actually going to go back to something that y'all have already seen on this part of it. And this is one that there's going to be a few test questions where it will kind of set up this way. And they'll kind of give you specific directions on this one, so they're kind of giving you a hint as to what to do for this one. They're going to ask you to rewrite and solve using the same base. Okay, and here's the big thing on this one. Here's the one thing you're kind of looking at. When they ask you to rewrite it, use it the same base. If you have the same base, if your bases are equal, which is the same, right? Then your exponents have to be equal. And that's the one thing they're trying to get you to see when you're doing this kind of problem, is that when they ask you to rewrite it with the same base, the key thing is that if you can make it so the bases are equal, then your exponents have to be equal, and then you're just going to solve what you need in the exponents. And a lot of problems, when you see these, you're going to look at the problem and you're going to go, oh, well, that's an easy enough problem. I don't really, I understand what's going on. So you have something like this. Okay, so we've got 2 to the x equals 16. This side's base 2, so they're telling you got to take this 16 and you need to rewrite it with base 2. And when you do that, it should be numbers that's they're not going to give you anything weird to go through this one. So if you think about 16, how many times have you got to multiply 2 by itself to get to 16? Because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that would be 2 to the 4th power. So if the bases are the same, now you can just look at the exponents, and you got x equals 4. And for that one, there you go. And you may be saying, well, that's easy. I can do all those in my head because all I got to do is just think about what the power is. It is, but on the next examples, they're going to make it so that you're going to have a little bit more work you've got to do to get it to the point where you can kind of do that. Because you may have something like this, where you got 3 to the x plus 7 equals 9. Alright, this one's base 3 over here, because that's got your exponent on it. So this one, you're going to have to rewrite this one so it is base 3. And again, it shouldn't be anything difficult. If you've got 9, that's the same thing as 3 to the 2nd power. And once you've got both sides written with the same base, you can take the bases out and then just look at the exponents. So now you can just do x plus 7 equals 2. And that one's pretty easy. It's just a one-step equation. Just subtract 7 from both sides. So x will equal -5. Alright, so far, everybody kind of get what they're doing so far. And again, that's one way they tell you. They kind of make it specific on this one. Is they'll tell you to rewrite and solve it using the same base. So they're going ahead and telling you ahead of time that you can take this number and break it down so it's got the same base as this base that's on the other side. And some people ask, well, how do we know what to do? This one's going to have a base with an exponent here. You got to take the number that's just by itself and break it down. Alright, for example 3. 4 to 3x equals 64. Again, there's your base with your exponent, so you've got to take the 64 and rewrite it in base 4. Okay, you start multiplying by 4s. 4 times 4 is 16. 16 times 4 would be 64. So 64 is the same thing as 4 to the 3rd power. And same thing. Once the bases are the same, now you can get rid of the bases and just look at the exponents. So now you're just going to solve 3x equals 3. And that's easy because you divide both sides by 3, so x is 1. Alright, now here's where they start to get a little bit tricky. A little bit creative. And this one's good to kind of throw this one out to you because sometimes if you don't see this one, sometimes people get a little bit lost. Alright, instead of it equals 6, we're going to take the same equation. We're going to change one little thing though. Instead of it just equaling 64 to start off with, now it's going to be 1 over 64. There you go. So for this one, the only thing it's going to do for difference on the answer is when you rewrite it, instead of it being 4 to the 3rd, it's 4 to the negative 3rd power. And this part's still the same over here. So if you, and somebody asked this morning in the first block, they said, does that mean every time you have a fraction here, it's going to be a negative? Pretty much, yes. If you see where you got a fraction instead of a whole number, that means you have to have a negative exponent. Alright, from there, same thing. Now the bases are the same, so it's 3x equals negative 3. So instead of the answer being positive 1, and the answer is just a negative 1. Alright, let's do another one like that one. A little different, but along those same lines. Let's do 5 to the 2x minus 1 equal to 1 over 125. Right, same thing on this one. You've got to rewrite this one in base 5. Right, and if that was 125 without the fraction, 5 times 5 is 25. If you multiply by 1 more 5, that would be 5 to the 3rd. But because it's a fraction, instead of being 5 to the 3rd, it would be 5 to the negative 3 power. Right, and then you're back to the same thing. Once the bases are the same, you can get rid of the bases and worry about just the exponents. So that's 2x minus 1 equal to negative 3. And now you're back to just a regular two-step equation. Add 1 to both sides. And then divide by the 2, so x would equal negative 1. And I know the last two came out to be negative 1 on that one. It's, you know, that number can be anything. It just depends on what happens with the exponents here. So it's not going to be negative 1 every single time when you go through this. Okay, and one more of these. This is the trickiest one that you get to just because of how it's set up. And if you can get this one, then everything else should be really easy when it comes down to it. Alright, so let's go with 3 to the 4x equals 27 to the x plus 1. Okay, for this one, 27 is your bigger number. We'll need to rewrite this in base 3. Okay, now, and again, for just a second, forget about the x plus 1. If it was 27, rewrite it in base 3. 3 times 3 would be 9. 9 times 3 would be 27, so that would be 3 to the third power. Now, here's what makes it a little bit tricky on this one. Is with the x plus 1, it's almost like that's in parentheses here, because it's more than just because everything else so far, we didn't have any exponents over here. If this already has an exponent here, you almost have to have an exponent that you just leave it in there. So when you've got the x plus 1 that's in the exponent here, it has to still stay in the exponent. So really for that part, once you've got your bases the same, now you've got 4x equals 3 times x plus 1. Because usually most people miss this one. They'll put that you've got the 4x, and they'll do 3 and put it in front of the x, but they'll forget to do 3 times 1 to make it 3. And for this one, once you subtract 3x from both sides, you've got the answer that you're looking for. Okay. And that if they ask you to rewrite it in the same base, that's about as bad a problem as you'll get. And it's more because you've got the exponent here, where all the other problems you didn't have an exponent over here, that you had just 27. You know, it was just 3 to the third. That one's a little bit tricky because they already gave you that exponent that was there. Alright, now, here's where we're going to kind of do something a little bit different than the way the book does it. Because the book problems in this part of section 5, I'm going to show you what they tell you to do, and if you're looking through the homework problems of how they would set this up, but I'm going to show you a whole lot faster, quicker, easier way to get the answer. Alright, for this part, this is where you're going to solve when the bases cannot be written the same. Alright, now, let me tell you what the book does. And I'll tell you what the book does, and we're going to look at this, and some people aren't going to like it, and then we're going to show you the way that I would do it, because it's a whole lot faster. So it's twice as fast as doing it the way the book's going to tell you. When they do it this way, and there are times later on, if you're going on into pre-cal, there's times where you want to do it this way just because of how it is, but the problems that we do, we can do it an easier way and get the same answer every time. So here's what the book says. And what we're going to do is we'll call this option 1 because, well, that's the first option. This is what the book tells you to do, but we're not going to do it this way. So to do this, you're going to rewrite the equation, and then you're going to attach. I'd say that's what it is, but that's basically what you do. You're going to attach ln to the base on both sides. And then you're going to use log properties to solve. Great. Let's show you an example of what they would do. This is where, again, this is how the book would tell you to do this problem. And we're going to show you a whole lot faster, easier way to do this. Alright, so here you go. We're doing 2x equals 3. And this is when you know you've got it, because you're going to look at 3 and you're going to say, okay, how in the world can I take 3 and rewrite it so it's base 2? Well, you can't. I mean, if you know what it is, you're a whole lot smarter than me, and you need to go ahead and just skip on through this class. Because if it was 4, that'd be easy. You can make this 2 squared. If this was 8, you can make it 2 to the third. But so it's something that's not a multiple of 2. So here's what the book says: is you're going to take the ln and you're going to attach ln to both sides of this equation. Alright, to use your log properties, now you've got this x that's in the exponent, you're going to pull that down in front of the ln of 2. So you make it x times the ln of 2 equals ln of 3. And to get rid of multiplication, and you got to divide. So that when you divide, those two things would knock each other out. You're left with x equals the ln of 3 over the ln of 2. And that would be what they would do with the exact answer, if they asked for an exact answer. Now, the good thing is they're not going to ask you in most of the cases for an exact answer. They're going to tell you to go ahead and use your calculator and clear this thing out and tell me what this answer would be. So we're going to show you with the calculator that, again, with your ln, there's your ln button right here. You do ln of 3. And if you want to, just to make sure that you don't do anything weird with it, I would go ahead and do ln of 3, hit equals, and then divide that by the ln of 2. And that way there's no messing anything up. That it's basically it's the top number divided by the bottom number. So that would be 1.585 rounded. Alright, and here's the thing. Most people don't like that. So, here's where we want to kind of catch everybody's attention real quick. Now, here's the easy way. We're going to do option 2. You're going to rewrite it. Well, we've got something that's in exponential form up here. You're going to rewrite it in log form. And then use your calculator. So we're going to take the exact same question that we've got here, and we're going to redo it using option 2 and show you how much faster this thing is. Okay, so we're going to take 2 to the x equals 3, take the exact same question, and now we're going to show you the easy way. Alright, if you rewrite this in log form, what's our base? 2, right? What goes there here? 3. X goes over here by itself. Can you do that with your calculator? Absolutely, right? So now you're just going to take your calculator, you're going to do log of 3 divided by log of 2, and just see what you get here. So if we do that, we've got log of 3, and again, if you want to be careful, just go ahead, I'd go ahead and hit equals, and then divide that by log of 2, it equals, and you've got 1.585 if you round off to 3 decimal places. So you can either take the thing and rewrite it with all the LNs, but to me the easier way is, and you can do this on anything that we do so far. If they give it to you in exponential, rewrite it in log and solve it. And we could even do that back here in the beginning when we did our first couple of problems, is that even back here, even though they told us to do it with the same basis, we could have taken this exponential problem and rewritten it in log form, because this would have been log of 16 base 2 equals x, and then you got your answer right there. So if they give it to you in exponential, rewrite it in log. If they give it to you in log, rewrite it in exponential, and you'll get your answers for whatever you need. So just do the opposite of whatever they give to you. We were doing that last year, and they were like, well, that's a lot easier. I was like, yeah, that is a lot easier. A lot less work to do this. All right, so here we go. 5 to the x equals 19. Again, no way you can take 19 and rewrite it base 5. If that was 25, yeah, we're in business. But with being 19, there's nothing you can do. So, if it's in exponential, rewrite it in log form. Log base 5. Switch the 19 in the x so it looks something like that. So now we're going to do log of 19. Get that number and divide that by log of 5. 1.829, if we won't round it up. Okay, and again, the key thing on that is just make sure you know how to use your calculator, that you've got to do the log of 19 divided by log of 5. And with those calculators we have, just make sure you close off that parentheses. They'll give you the first one, just make sure to close it off the second one. Alright, here's one with a little bit of a twist to it. You've got 3 to the x plus 2 equals 17. Still going to do the same thing for this part. When you set it up, you're still going to do the same way. Rewrite it in log form. So you've got log of base 3. 17 goes here. X plus 2 goes there. The only difference is, instead of this answer just equaling x, we got to do x plus 2. So once we figure out what this side is, we got to do just a little bit more work to it there. So we've got log of 17, close it off, divided by log of 3, close it off. So that is 2.579 if we go 3 decimal places. So if you have 2.579 with x plus 2, that means you got to subtract 2 from both sides. And when you do that, you get 0.579 for your x. Again, just take your answer you had here, just do minus 2, and you're back in business. Okay, so if they give you something in exponential, and even back to the earlier problems, where even though they said to rewrite it with the same base, if you get stuck and you're not sure what to do, if they give it to you in exponential, rewrite it in log form. The next 2 or 3 problems we're going to do, we're going to give you log form. So I'll tell you to solve the log equations or solve the equation that's written in log form, something like that. And again, all you're going to do is you're just going to rewrite it in exponential. So if they give you exponential, rewrite it in log. They give you log, rewrite it in exponential. Alright, so here we go. Log of 2x equals 1. Alright, first thing on this one is, it doesn't have a base. So what is the base supposed to be? 10, right? So take that problem you've got, rewrite it first, so you got log with base 10. And once you got it here, now you go ahead and rewrite it. So base stays the same, so 10 is your base, and then just switch these two numbers, so it's 10 to the first power equals 2x. And 10 to the first power is about as easy as it gets because that's just 10. And if 10 equals 2x, divide both sides by 2, so x is 5. There you go. Okay, so something that looks kind of bad in the start of it, when you start working on it, it's really not as bad as you think. So for this one, let's do log of 2x plus 1 base 3 equals 2. And that's why we kind of reviewed in the beginning, because if you can take something and rewrite it in log form to exponential, when you solve it, well, now the solving is going to be really easy because the numbers are going to be there, and you just basically just use your calculator. All right, so this one, we got our base, so we can just rewrite it. 3 is our base, and once you've got your base, to take it out of log form, you just switch these two parts. So it's 3 squared equals 2x plus 1. And again, 3 squared is easy, that's 9. And now you're back to solving just a regular two-step equation. Subtract the 1, and then divide by 2. All right, now here's where they try to get a little bit tricky with you. All right, everybody good there? Everybody still writing that one down? I'm going to cover this one up a little bit, just so we can kind of go back here. Okay, so when you've got the two logs here, before you rewrite it, in exponential, you've got to condense the two logs into one. And to do that, that's where you're going to have to use your log properties. And again, that's the properties we looked at yesterday. And there were only 3, so there's not that many options you've got to worry about it. But we're going to take these two logs and get it back so it's just one log equation to make this thing work out. All right, and if you go back to your log properties, if you had a plus in the middle, do y'all remember what we had to do with these two things? Had to multiply. So you're going to do log of 2x times x equals 1. All right, and again, there's no base on this one, so I would say go ahead and put your base 10 here just so you've got it. And if you do 2x times x, that's going to be not 3. How about 2x squared? All right, now you've got it down to just log of something, and now we can take this thing and rewrite it. So once we rewrite it, it's 10 to the first power equals 2x squared. All right, and to get the x squared by itself, you're going to have to divide both sides by 2. So that's 5 equals x squared. All right, and flashing back to chapter 2, how do we solve, or how do we get x squared down to just x? Square root it. There you go. Oh, thanks. All right, so square root both sides. Good answer. Alright, so square rooting it, you get your square root of 5 would equal x. And again, if they ask for an exact answer, that would be an exact answer. and we're not going to do the plus or minus, just one answer for this one would be okay. If they ask for it in decimal form, you'd actually take the square root of it. That'd be like 2.236. Okay. So that's the only thing that's a little bit different. If they happen to give you 2 logs or 3 logs, you've got to condense them down so it's just a log of one expression, and once you do that, then we're good to go. Alright, I'm going to show you, that's 7.5. Let me show you one thing in 7.6. Actually, 2 things. It's one thing forward and one thing in reverse. Let me show you that one thing that we have here, and then that'll wrap us up for the day. That in 7.6, you're going to solve natural log equations. And again, when you're talking about natural log, that's when you're going to have the ln. Okay, now here's the one big thing that goes with this one. Actually, it's 2 things here. To cancel ln, because if we have an equation with ln, kind of like we had logs, you've got to get rid of the log part and get it back so that the log is gone. And ln is just the natural log, so it's kind of the same thing. So to cancel ln, you're going to have to take e to both sides. And to cancel e, take the ln on both sides. So kind of like when we had something in exponential form, you would rewrite it in log form, or if you had something in log form, you'd rewrite it in exponential. This one, if they give you LE, you got to take e to both sides. If they give you e, you got to take the ln to both sides. So they're going to kind of cancel each other out.
Oh wait, we're in the second block. Okay, thank you.
Alright, so here we go. We'll do 2 examples of each one of these, and that'll wrap us up. One easy one that's a little bit more difficult, and then we'll do the same thing in reverse and kind of get that. Those of you that just came in late, make sure to get these couple examples written down, because the other stuff I can show you how to get caught up on these, the other part of it real quick. Alright, so e to the x equals 12. So you've got e, you got to take the ln of both sides. So all you're going to do is you're going to take the ln of the left-hand side and take the ln of the right-hand side. And if you have ln and e together, and I'll show you this on your calculator, and this one's a little bit different, but we'll do that. So if you do ln here, and then if you do the e button with it, now it gives us e to the power, so I'm going to do it to the first power because it's just e. If you do ln and e together, it knocks itself out. So if we did the, let's see if this will work here, ln of e to the 5th power, the ln and e are going to cancel each other out, and you're going to get just a 5. So if we do the ln and e together, they knock each other out, and you just get x by itself. If they ask for an exact answer, that would be your exact answer. If they ask for a rounded answer, that's where you're going to use your calculator, do ln of 12. That is 2.485 if we round it off to 3 decimal places. Okay. One more example with an E, then we'll do a couple with an LN, and then that'll wrap us up here. Alright, for this one, we'll go e to the 3x plus 5 equals 15. And this one has one little catch to it. That before you can take the ln of e, or the ln of both sides, you have to get e to the power by itself. And to get the e to the power by itself, it's never anything too complicated for now. If you're going into pre-cal, of course, they'll make these problems a little bit harder. But for what we're doing right now, it should be a pretty simple thing to get the e by itself. If you've got e to the 3x plus 5, how do you get rid of plus 5? There you go. It's minus 5, right? So that's e to the 3x equals 10. And once you've got the e by itself, now you can take the ln of both sides. So you've got the ln of e to the 3x equals the ln of 10. Write it down so we have a bit more room here. And again, the ln and e kind of cancel each other out, so you can just basically get rid of it there. So that leaves you with 3x equals ln of 10. And again, because it's 3 times x to get the x by itself, go back and divide both sides by 3. And when you do that, of course, 3's cancel and leaves you with that. So that would be your exact answer. Alright, again, here's another good calculator practice, because you have to be a little bit careful with that one when you plug it in. Because when you do the ln of 10, and again, if you get the top part, I would go ahead and just get that number, and always close it off, hit equals, and then take that answer and then divide it by 3. So that'd be 0.7675, so 0.768. Because sometimes people, especially if you get in a hurry, if you do ln of 10, if you don't close that off, if you do ln of 10 divided by 3, you're going to get a different answer than what you were supposed to get there. So just be careful that whenever you do the ln of 10, just make sure to close that number off before you do anything else with it. Alright, and then the last two problems. Do the ln of x equals 3. Okay, and this one we're going to do the opposite. This time you've got the ln. To cancel the ln, you're going to rewrite both sides. With base equal. Okay, so all you're going to do then is put e on the base down here and e to the base down there. And as long as you can get the e and the ln to touch each other, they be right beside each other, then as long as they're beside each other and they're connected together, they cancel each other out. So x would equal e to the 3rd power. Again, that would be your exact answer if we plug that in. Your e is back here behind the ln button. There's your e, put the 3rd power in. That is 20.086. Okay, so here's your exact answer, and here's your rounded off answer. Alright, last one. class. What's different on this equation than that equation? How many LNs does this one have? It's got 2. This one's only got 1, right? So before we can solve this one, we've got to get these 2 LNs condensed down to just that one right here. So we're going to have to do the ln of 2x plus 3. Alright, so condensing these 2 back together with the plus in the middle, that means you got to multiply. 2x times 3 is 6x. And once you got the 1 ln, now you can take the e to both sides. And once you've got the e to ln, those 2 things knock each other out. Got 6x equals e squared, or e squared over 6. And if we take e squared, again, I'd say close that number off, get it to e squared first, which is that 7.389. Then go back and take that answer and divide it by 6. We get 1.232 for a final answer there.